So if you watched the last segment, simplifying those fractions was pretty easy. This is a bit nastier. And so we were asked to write this in simplest form. And the numbers you'll notice are quite a bit bigger than the last section. And so we have 63 over 18. And we've got to try to think of a number that goes into both 63 and 18. And so if you have a multiplication table handy, that might help you out. But I noticed right away that 9 goes into both 63 and 18. And so 63 divided by 9 is 7. 18 divided by 9 is 2. And so that's going to be the fraction in simplest form, but it is improper, meaning that the number in the numerator, the 7, is larger than the number in the denominator, the 2. And so I don't know if Alex is going to take that or if it's going to make us write it as a mixed number. I sort of hope that it takes it. It does. Very good. So we'll talk about mixed numbers later on. But for now, this is going to work out okay for us. I do want to do this problem again. And this time, I'm going to not recognize that 9 works. I'm going to say, I've got 63 and I have 18. And I'm going to notice that they're both divisible by 3. And so this will still work because 3 does go into each of them evenly, but we're going to end up with 21 over 9. Now, 21 over 9 is not the most simple form of this, because if you look at 21 and 9, you would notice that 3 is a common factor of 21 and 9. They're both divisible by 3. And so to get this fraction into simplest form, we would have to do another step. We would have to divide again and recognize, oh, they're still divisible by 3, so I need to do that. And 21 divided by 3 is 7. 9 divided by 3 is 3. And I don't, oops, that shouldn't be a 9. That should be a 6. I was trying to figure out what the heck was going on there. So Schlegel makes mistakes once in a while. We all do. All right, so we would still end up with 7 over 2 as our fraction in simplest form, because sometimes you just won't pick the biggest number to divide evenly into the numerator and denominator. And if you don't, that's okay. You just end up having to do a second step right here, where we notice that they still have a number, they still have a common factor, and so we just need to divide a second time. Okay, let's try another. We have 36 over 27. Okay, 36 and 27, I know that 3 goes into both of them. I also know that 9 goes into both of them. And so if I was to do 9 right away, I think I would be finished. So I'm going to go ahead and pretend that I don't notice that 9 works. And I'm going to use 3. So 36 divided by 3 is 12. 27 divided by 3 is 9. And at this point, we need to recognize that we're not done, because 12 and 9 still share a common factor. They are both divisible by 3. And so we end up having 12 divided by 3 is 4. 9 divided by 3 is 3. And our simplest form for this one is going to be 4 thirds, or 4 over 3. All right, and then 81 over 72. Incidentally, these are both divisible by 3 as well, but I am going to instead this time recognize that I can divide them both by 9. If I divided them by 3 the first time, I would just have to do that again a second time. And so 81 divided by 9 is 9. 72 divided by 9 is 8. So 9 and 8 do not share any common factors. And so simplest form here is going to be 9 over 8. And I will do one more because this seems to be an area that students can use some help in quite a lot. That one's really easy because it's 5s. This is a bit of a weird one. Let's do this one. So 20 over 28. We're going to do this one twice. The first time I will just notice that they are both even and I will divide by 2. So I end up with 10 over 14. Now I look at 10 and 14 and I recognize, hey, look, they're both still even. So I could divide by 2 again. And I end up with 5 over 7. 5 and 7 do not share any common factors, and so that would be the end there. Alternatively, I could have noticed that they're both divisible by 4. And I would end up with 5 over 7 straight away without having to do the division a second time. I hope this is helpful, and I hope you have an awesome day.